Okay, so this is example 2, and so our f of x, we're going to find the composition of functions. We're going to find, well, f of x is x squared plus 3x minus 4. Its domain is all real numbers because it's a polynomial. And g of x is 1 over 3x minus 2. Its domain is minus infinity up to 2/3 and 2/3 on, so 2/3 to infinity. Now I'm going to find f composed of g. I'm going to find g composed of f, f composed of f, and g composed of g of x. All right, so we're going to go ahead and go on to the next page. So f composed of g of x means that I'm going to take f and evaluate it at g. All right, so g is 1 over 3x minus 2. And the domain, since f has all real numbers for the domain is going to be restricted by what g can be. So we can't use 2/3. Because we can't use 2/3 into g, I can't use 2/3 in the whole thing. All right, so f of 1 over 3x minus 2. And then f of x, remember, is x squared plus 3x minus 4. Okay, so that goes in each one of those parentheses. So I get 1 over 3x minus 2, 1 over 3x minus 2. Okay, so I'm done finding the composition. What I need to do now is simplify. So I apply the exponents. So 1 squared over 3x minus 2 squared plus, now when we multiply across the top and we multiply across the bottom. And then we have minus 4. Okay, 1 squared is 1, so I end up with 1 over 3x minus 2 squared plus 3 over 3x minus 2 minus 4. Then I have to go on to the next page to continue. So here I'm just going to rewrite what was on the last line there. Okay, now to simplify this, I need to get everything over a common denominator. And this is going to be my common denominator. So here I have 3x minus 2 squared. I need a 3x minus 2 squared here. So I'm 1 short. What I'm going to do is multiply on top and bottom by 3x minus 2. And so that gives me a 3x minus 2 squared. Here, I need a 3x minus 2 squared, so I also have to do that in the top. Because remember, I'm looking for the common denominator. And now everything is going to go over 3x minus 2 squared. So I get 1 plus 3 times 3x minus 2 minus 4 times 3x minus 2 squared. So I get 1 plus, I'm going to distribute here, 9x minus 6 minus 4, and now I'm going to expand this. So on a separate sheet of paper, I'm going to write down 3x minus 2 times 3x minus 2. I'm going to expand that, and I'm going to get 9x squared minus 12x plus 4. And now I'm going to distribute. Again, I'm going to have to go to the next page for that. 1 plus 9x minus 6. And then minus 36x squared. Plus 48x minus 16. And the denominator is 3x minus 2 in parentheses squared. Okay, so I get 1 minus 6 is minus 5. Minus 5 minus 16 is minus 21. I have 9x and 48x, so it's going to be 57x. And then I have 1 x cubed term. And so finally, after all of that, I get to my answer. That's my f composed of g of x. Okay, now we're going to look at g composed of f of x. So again, immediately I rewrite this as g evaluated at f. So I get g evaluated at, and f is x squared plus 3x minus 4. So in my g, I write down g of x. It's 1 over 3 times x minus 2. And I plug in for x, I plug in this thing, x squared plus 3x minus 4. Now, to simplify, I'm going to expand. And combine like terms, and I will be done. Except I need to talk about domain. Okay, so the domain I'm not actually able to find because, so here's what the, okay, so the domain of g of x was x couldn't be minus, 2/3. So since f of x goes into g, f of x can't be equal to 2/3. However, this is a quadratic, and next week we'll be studying how to solve them. So right now all I'm going to say is that f of x can't equal 2/3. No, let's see, did I get, yeah. Okay, and now we're going to look at f composed of f of x. So that is f evaluated at f. So f is x squared plus 3x minus 4. So when I plug that in, so f of x is x squared plus 3x minus 4. So this goes in here. Okay, and because f has domain all real numbers, f composed of f has all real numbers. And I'm not going to, so I could simplify this, but it would require me to multiply this out. And I think that really I want to focus on plugging in for the composition functions. All right. The next one is G composed of G of X. So that is G evaluated at G of X. So that is 1 over 3 times X minus 2. Oh, let's see. I skipped something I normally do. So G evaluated at what G is equal to, so it would be 1 over 3X minus 2. And so that goes in wherever there's an X. Okay, now I can, the next thing I'm going to do is give the domain. So we said for the original domain of F, of G, that X could not be 2/3. So when I use G of X, what happens is X still can't be 2/3 because I can't plug that into G. But also, I can't have G of X equals 2/3 because if G of X equals 2/3, I'll take this G and evaluate it at 2/3 and divide by 0. So I need to look at my G of X and see where it's equal to 2/3. So this is a ratio. I can cross multiply. So I get 3 times 1 equals 2 times 3x minus 2. So it's going to give us 6 minus 4. So 3 equals 6x minus 4. Add 4 to both sides. And we get 7 equals 6x. So x can't equal 7 over 6. Because if x equals 7 over 6, G of x would be equal to 2/3, and then I would evaluate this G at 2/3, causing the denominator to be 0. Okay. So let's talk about simplifying our G of x. So G of composed of G of x is 1 over 3 times 1 over 3x minus 2 minus 2. So the first thing I do is multiply this. This is 3 over 1. Multiply across the top. Multiply across the bottom. Now I need common denominator, so I take the 2 term and multiply it by 3x minus 2 on top and bottom. Now what happens? I have 1 over 3 over 3x minus 2 minus 2 times this stuff. All right, now I have a common denominator. So I can put all this stuff over the common denominator. Okay, we're getting there. We need to distribute here. And minus 6x was it plus 4. All right, so I can combine the 3 and the 4 together to get 7 minus 6x over 3x minus 2. So I take the 1 on top and multiply it by the reciprocal, and that is my final answer. That is G composed of G. That was my last example, or last problem for this example.